let's say, deployment by, discovering early, before they get to you, some attackers' sources, let's say. So, Fred, thank you again for coming, taking a long journey from USA. Not the same weather like Florida, but still good enough for Berlin. Thank you again. The floor is yours.
Thank you. It's awesome to be here. This is my favorite conference and my favorite place to be. So it's great to be here with all of you today. Today's presentation is APIBan and Kamailio. So the agenda I'm hoping for is who am I? That will be extremely quick. What is APIBan? What's new with APIBan? APIBan clients and tools. Integration with Kamailio. And then questions, ask me anything. And then for our trivia today, and I'll do the David Duffy. Does this agenda sound good for everyone? All right, great. Okay, anybody know who that is? Anybody old enough? That is Rowdy Rodney Piper, who came up with a great phrase of, I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum. All right, so let's do it. Who am I? I'm Fred. I'm based out of the United States. I consult with LOD.com and former baker with my beautiful wife up there. That's our daughter. You can see her running around. You can contact me through fred.tel, and I helped found APIBan in 2020. So what is APIBan? APIBan is a free service to help prevent unwanted traffic to your systems. Okay, and it's free thanks to our generous sponsors. We started in 2020, and it started from conversations that we had here at Kamailio World. At one point I was thinking about doing something with DMQ to, we're all getting attacked by these similar IP addresses. How can we share information to keep ourselves from being blocked? I was also originally going to use just HTable and see how I could do it within Kamailio. And I spent a good couple days on that, and I decided that there's really no reason to reinvent the wheel. I could, but much like Jurassic Park, just because I could doesn't mean I should. So I decided to instead deploy something based on this. APIBan sits at the LOD data center, and we have behind an F5 a couple HTTPS nodes that then connect to a Sentinel cluster to gather information in real time, try to keep things as quick as possible. And then for long-term data and storage, we use a Galera cluster. So it's pretty simple. The API itself is written in Go. We have an API reference for you if you wanted to connect, because basically all we are is an API that tells you if an address is bad or good. We collect these IPs by honeypots located throughout the world. If an IP hits a honeypot, it stays active for 7 days. That's an arbitrary number that we made up. I like it, and it sticks. All right, and then many IPs are relisted within minutes of becoming inactive. So, it's good to just keep it up there. It does SIP, so we listen on UDP, TCP, TLS, TCP, and now we also do HTTP and S to help with free PBX and some of those phone provisioners out there. That was a change requested by one of our sponsors, which is, hello, thank you guys very much. It's a free service because of our generous sponsors. All you have to do is get to the website, you get a free API key. NetSapiens, Jambones, Clearly IP, LOD, those are the big sponsors now. Huge shout out to Ivan, who moved, nope, he's right back there. And you can visit his website at quanlabs.com. Ivan helped us with many honeypots in the past and current, as well as, I think it's almost 2 years ago at this point. Ivan goes through and analyzes traffic here and there, and he found an amazing proxy registration attack that was just a wonderful exploit that Sandro even helped us try to figure out. Acipto helped sponsor us and integrated it through CAM-CLI, and we have GitHub sponsors. Ben Kaufman, Jose Franco are current ones. In the past, we've had generous sponsors from like SIPfront and things like that. Last year, we blocked 83,466 IPv4s. Okay, we blocked 0 IPv6. We didn't get hit by a single one. 2026 might be our year. Of those that were blocked in 2025, 16,000, give or take, were brand new IPs for us just last year, brand new. For on the HTTP side, 111,457 IPs blocked. So we can block them or you can get hit by them, one of the two. So what's new with APIBan? We added a flush after feature. It's like third down there. It's my favorite. All right, so like I said, we have a feature that says an IP is active for 7 days. If you are using our APIBan client, which we'll get to in a minute, you would automatically flush the cache of your IP addresses every 7 days. Now you can choose to keep that period longer. Like I said, some of these are updated within minutes. If you want, you can keep them 30 days, 45 days, however long you want. You can change that. So that's a setting. The default, again, is 1 week, but you could go shorter or longer, however you want. Choice is yours. Uptime is a new feature for when you reboot your system. It now says, oh, okay, I've been rebooted. Let me go ahead and pull the entire list again. Otherwise, it's just getting the ones from the last time it got. So uptime is really useful when the system is rebooted. We support YAML, or however it's spoken. Our configs had always been in JSON, or JSON. And we added an NF tables client because, as you saw, some of those IP address numbers that we had are absolutely enormous. I joked years and years ago that I wanted to retire before IPv6 became a thing. I really hoped I'd never have to do anything with NF tables, but I actually love it now. I'm really happy with NF tables. Everyone should switch. It's great. But NF tables client, and we also created a local API so that you can manage your own NF tables entries via HTTP. So speaking of those clients, the clients that we have with APIBan, the first one I want to bring up is APIBan client NF tables. All of our software is and it's a generous term to call what we make software. But if you go to APIBan on GitHub, it's written in Golang, so you can build it yourself, or we have it compiled for you. You get to choose your data set, SIP, HTTP, or both. It's called all. It's documented right there in the README. It tried to be as good as any open source README is. You can add to a set in NF tables, and what I love about the way that we use NF tables here is that it's going to block both incoming and outgoing to that IP. So you're not going to send anything to the outgoing IP as well. Simple install script through Bash, or you can build it yourself. The original one was API Client Go, and that's just basically the same thing, but for IP tables. There are so many active IPs now. So generally, you're looking at thousands of active IPs. So especially if you're going to use a data set of all, of HTTP and SIP, I really recommend that you go to NF tables. It just, for the rebuild of it, it handles huge data sets of IPs much more efficiently than IP tables, is what it comes down to. And it's all about saving your CPU for handling real-time communication. We have a Bash client. This one hasn't been updated in a long time, but you can use it for IP tables or NF tables. It's an old client. It's written in Bash. You can do whatever you want with it. It's ugly and it works. We've made some Go libraries to help people. So we have a Go library for APIBan commands. So if you wanted to build your own Go application and just use some of our polls and things like that, you can just use that library. It's not well documented, but it's there. And we also have a library for dealing with NF tables for adding and creating data sets, creating filters, things like that. There's an APIBan fail to ban integration. This was designed mostly for people running like FreePBX or something like that, which people in this room might not run, but your clients definitely do, right? So you could give them this, and it will just integrate with their fail to ban. So whatever they're running, if they're running NF tables, IP tables, whatever, it just integrates right with the fail to ban. It defaults to asterisk, which is the FreePBX jail, right? But you can change that as you wish. It's really simple to do. And the last software I want to touch base on is NF Tables API. And this is that local HTTP API for adding or removing IPs through NF tables. And it supports IPv6, IPv4. It can do add, remove, flush, and it has multiple ways of doing it, because my whole problem with fail to ban was that I could never remember how to remove an IP. And when you have to remove it, you're already in a stress, and it was just so, here if you send it block, it's gonna block it. If you send it add, it's gonna add it. It's block IP, it's gonna block it. It just tries to figure out what we're doing and just does it. And then I think Dan Jenkins pushed me where if you do a push, it adds it as well. But so it's a fun little API. It's well documented on GitHub there. But let's talk about Kamailio. So the reason that APIBan exists is because we're all into real-time communications, right? And it's gotten so bad out there that we all joke about it probably when we load up a system, that you load it up and you can immediately start seeing traffic, right? So, I mean, it's actually one of the great things now about just testing to see if you're connected to the internet, right? There's a couple ways we can approach life. So if we're in a smaller providing circle, maybe we just allow list IPs, right? So we, by default, block everything, and then we only allow the certain ones in. That would be great. But in reality, if we're selling to customers that might have dynamic IPs or something like that, or can't do VPN or anything, in reality, we're probably going to be open to the internet, and we have to deal with it. APIBan will not block targeted attacks against you. So if you're out there and you're attracting attention, people are going to find you. What APIBan does is it goes against the scanners, which is what we're seeing a lot of traffic, just going and finding the scanners, listing you in certain areas, and then, oh, okay, look, I found this, I found a password, now let me send it to someone else to do the full attack. Skipping that first step helps you a lot in getting the second attack. But APIBan itself is just, preventing the scripting and the honeypot attacks. With Kamailio, there's generally 4 different ways to integrate. One is CamCLI. Victor probably has the neatest use I've seen of that. You can use APIBan clients, which is what I really recommend. You can also use the Kamailio config, which is awesome, and you can also do a hybrid approach there. And you can use Chemi. I'm not going to talk about Chemi, but basically Chemi, you can use, if you're running your scripts in Python or whatever you want, your config, then just do an API calling however you want. You do your own API and you handle it there. That's the beauty of Chemi, right? CamCLI is Python. It gets installed, I believe, by default now. You can run a check, a load, which loads all the records into HTable. You can check a specific IP address, and you can also show the IP addresses that are listed in HTable. So you can run some sort of cron job or something that automatically loads records into HTable and just let IPBan within your config handle it that way. So that's one way of using CAM-CLI. I really like the APIBan clients, and here's my main reason for doing it. Okay, so we all love talking about the OSI layers, right? That's our favorite thing to do, other than telling SIP jokes, right? So Kamailio runs in layer 7, right? It's software. So if I'm checking each IP, I'm taking away CPU that I could be using to handle real-time communication. And as I like to hammer to any of the deployments I do, I want all CPU possible for Kamailio. And when it uses more than 1%, I'm getting scared. But you know, I want it to have all the CPU. I also want it to use none of the CPU. So IP tables runs in layer 3 and 4. It's just more efficient. The kernel's doing it. NF tables basically runs in 3 and 4. There's a way of doing it in 2. I'm not an expert on that. But it's also much more efficient. So I did a sustained attack, and I did that I think a few years ago. I showed the difference. But if I did a sustained attack at, let's say, 1,000 per second, even if I was blocking it in H table, so I wasn't doing an API lookup all the time, but I was using Kamailio to just exit, I'm running 10% CPU at 1,000 calls per second or something. If I was using IP tables or NF tables, it's negligible. You know, almost nothing. It's just happening in the kernel, and it's very, very efficient. So significantly reduced CPU under heavy load. And NF tables is excellent for these large address pools, right? I don't have to say, okay, I need an H table that can support, you know, 40,000 IPs or something. I'm going to give you some examples that I like to do for configuration. They're also on the APIBan website, so don't worry about writing them down. We could just go over them. I also have these slides online, and there'll be a link there. The big too long didn't read is the default Kamailio max while loops, I think is either 100 or, yeah, I think it's 100. You want to increase that to 600 because APIBan looks for IPs in batches of 600. So if you don't increase your max whiles loops, you're only going to get the first sixth of the, and it's just not going to work. So you increase max while loops to 600, and then basically we can accomplish it with as simple as 3 modules, HTTP client to get the API info, Jansen to parse the JSON, or JSON if you'd rather do it that way. You know, we have over a few hundred modules for you to choose the one that fits you best. And then our timer so that you could say, okay, every 4 minutes I want to go ahead and check for new IPs. So this would, and there's where the top in bold has where I have these slides, so you can just grab the config there. But I'll choose the middle one here. In the beginning, I'm setting for an H table. I'm just saying, okay, I want an APIBan H table to store all the IPs. I'm going to make it a size 14, which should cover everything, and 60,000 or 604,800 is 7 days. And so I'm going to automatically expire them after 7 days. I'm also going to keep a control which has the ID of the last IP I grabbed. So I'm going to then set our timer to look every 5 minutes or 300 seconds, and I'm going to put that in a context called APIBan. So my route APIBan just grabs my key, goes to the API, pulls from the last ID, and adds it to the H table. So basically all this is doing is saying, I'm just going to parse through the JSON. As long as I'm more than 0, then I'm going to go through. If at the end of everything, if I haven't reached 0, then I'm going to go ahead and check it again. And then somewhere in your code, if the source IP is in APIBan, then exit. You know, it's that simple. You can even keep count of how many blocks you're doing or something like that. And then if anyone's used mod init from htable, you can preload that route whenever you start Kamailio. So as soon as Kamailio starts, you load the IPs. All that being said, The fact remains that the NFT client provides better performance, especially if you're under attack. Now, the NFT tables API that I talked about before, I love integrating this with Kamailio. This is my favorite part, because as I said, the APIBan is getting the general attacks out there, right? Things that are hitting the honeypot. But if someone is directly attacking you, it really helps to block that, not within just Kamailio, but maybe at the kernel level itself. And that's where this NF tables API came out. So with this API, we get incredible flexibility. You can block anything, you know, block it by user agent, account, country, whatever you want. If something fails the core parser, you get, as famous like 4 or 5 years ago, someone was sending DNS to your port 5060 there. You know, you can say, okay, well, someone's attacking me with DNS, let me block them. You can do slow registration attacks. When they hit a certain threshold, block them. And this is how we can definitely keep out bad traffic at the kernel. And so it's one of my favorite implementations. So let's first talk about the core parser. So this is right part of the core module. You get a core receive parse error event route. So what I would do is normally, it's something as simple as here. If I have something that triggers that event, then I'm going to go to my block IP route. Okay, and this is what my block IP route might look like. So as the example is, I'm not going to block myself. Let's say it's my local media server. You know, again, this is just an example. Or anything that I have as specific allowed IPs I don't want to block. As long as it's not one of those, I might do a log notice. I'm going to set my IPBan to that IP, set it to 1. This one's using client as sync. I'm then going to go to block IP is the one I chose there, and then it's blocking it. So now I've blocked that IP in the kernel. For extra credit, you could do whatever you wanted for your expiration term. So let's say your IPBan was 2 hours or 2 minutes, whatever you want. When it expires, you can automatically remove that IP from being blocked. So you could dynamically add it and remove it. You don't have to leave something as permanently blocked. And so this one will do that, and it will also log, in this example at the info level, that it removed that IP. For slow attacks, I just flat out stole this from Daniel. A few years ago, he showed a way of checking for slow attacks. And for this example, we're doing it in 30 minutes. If they try, a bad password every, 5 times within 30 minutes, I'm blocking them. It's that simple. So this, again, I modified it a little bit, but it's basically just flat out stolen. And that's on the website as well. Or you could do whatever you want. If it exceeds your Pike module, do it. For user agent, I've specifically called out Sandro, as well as friendly scanner. And then SQL inject, things like that. So have fun. You can do whatever you want. If you don't like PJ SIP, block it, the user agent, however you want, And that brings us to the questions part. Again, I just want to say how happy I am to be part of this community. Thank you all for supporting Kamailio and everything that you do. This community means the world to me, and I'm so glad and honored to be here today. Thank you. Looks like Tori was first. I think Tori was.
Tori. Oh, I still don't have my back eyes.
Hi. I actually have 2 questions, if that's allowed. The first question, one We currently use the APIBan in the H-table method, and one of the things we like is as in your example, doing a count to see how much traffic's actually blocked, but also keeping track of how much per IP address traffic blocked, so then we can know if we accidentally blocked an important customer or something like that. I was wondering, is there a good way I think with IP tables, there's a way for a chain the number of times it's invoked. Is there a way to get similar counting stats from the NFS tables?
Yes. The flat out answer is yes. It's just putting a count in there. The default way that this chain gets added doesn't do it, but even just you bring that up means that I have to add it. So I'll add a method of adding a flag where you can add the count method so that you could, so that the data set will show you how many times an IP has been hit.
And you showed another example where you were having the H table, and then it was syncing via the API, NFT API to the to the NF tables. And the thing that comes to mind is, and then you're doing the cleanup. But what happens if you restart Kamailio? So you lose the H table. What do you do in that case?
So that's a great question. I'm sure everyone heard because he's mic'd. Normally when in that mod init, if I'm running NF table API, I'll start off with a flush. So there's a flush command that you could send, and that flush command will allow you to to just empty out both the IPv4 and the IPv6 tables.
Okay, one more question and then two. Okay, two. And then we go to the next presentation.
Thank you for the session. I have a basic question. So in a WebRTC world, the real endpoint which is attacking, right? The IP that you receive may not represent the actual endpoint's IP, right? So an entire office or an entire building may be behind that particular IP. So how intelligent is the APIBan to block such kind of attacks which comes from a natted or a turn server IP?
Yeah, so I guess this would be, can everybody hear me if I talk this? I think I lost my mic or something. If, I guess spoofing is the question, like how do you handle spoofing? You know, I really don't see spoofing that much, especially on UDP. It's been very difficult to see it make it to a Kamailio instance that traverses the public internet. It's not impossible, but it is, right? So I still like the source IP method because, again, I don't see spoofing that often. But there are ways in Kamailio. If you looked at some of the tutorials, I think even the default config might have a spoofing example. And when I do see spoofing, I'm blocking anyway, and I'm not letting that go through to begin with. But spoofing, generally, I would want to see handled on like a router or the OS.
Okay, like last quick question.
So I will just add on to his question. If Kamailio is running behind the load balancer, Kamailio won't be seeing the actual source IP. Does NF table will help in that place also?
Yeah, so if you're running it behind a load balancer, you know, I'm not a huge fan because I consider Kamailio the better load balancer there. So I generally don't, but if you are running it through a load balancer, then you're probably not going to be able to use the client, and you would have to use the H-table method or Kamailio itself, and then go for either whether it's an X header that the load balancer is adding or something within the VIA or something like that.
Okay, thank you, Fred.
Thank you all.
You can find him today, tomorrow for further.